This video covers the review for section 3.2. Sum or difference formulas for sines and cosines. The formula for the cosine is the cosines repeat, but the sine alternates, and the sines repeat. The formula for the sine is the sine and the cosine alternate, and the sine repeats, the minus. Now, the pluses of those, the cosine of the x plus y, changes the sign between those. And likewise, the plus for the sine changes that. Sign between them. Okay, so those are the four formulas that we use for these. So with these formulas, it allows us to come up with the cosine of some of our non-standard angles, like in this case, 75 degrees. Since 75 is the sum of 45 and 30, we use the sum formula, cosine x plus y. Cosine first, cosine second, minus sine first, sine second. Now cosine 45 is rad 2 over 2, cosine of 30 is rad 3 over 2, sine of 45 is rad 2 over 2, and sine of 30 is 1/2. So that gives us square root 6, square root 2, they're both over 4, so we get square root 6 minus square root of 2 over 4. Now 195, we need to find that as the sum of two of our standard angles. When I see a 5 on there, I'm thinking that it's got to be some kind of 45 degree angle. So there's a couple of different ways we could go about this. And so I thought of this as 135 degrees, and then another 60 degrees after that. So I thought of this as 60 plus 135. All right, so then this is the sine of 60 plus 135. So we've got the sum, sine of the sum. And so we take the sines and we alternate them this time. Sine of 60, cosine of 135. Plus the sine of 135 and the cosine of 60. Sine of 60 is root 3 over 2, and the cosine of 135, that's a 45 degree reference angle in quadrant 2, and cosine's negative there. Sine of 135 is root 2 over 2. And the cosine of 60 is 1/2. So this gives us negative rad 6 plus rad 2, all divided by 4. Sine of the difference is sine of pi over 4 cosine of pi over 3 minus sine of pi over 3 cosine of pi over 4. All right, sine of 45 is root 2 over 2. Cosine of 60 is 1/2. Sine of 60 is root 3 over 2. And cosine of 45 is rad 2 over 2. Our denominator is going to be 4, and we'll have root 2 times 1 is root 2. Root 3 times root 2 is root 6. Root 2 minus root 6 over 4. $15 degrees. Is there a way we can subtract two of our special angles and get 15 degrees? Yes, 45 minus 30. So we have the cosine of 45 degrees minus 30 degrees. The cosine does cosine, cosine, sine, sine. It does the same, and then it alternates. So cosine 45, cosine 30, sine 45, sine 30. Cosine 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. This gives us root 6, root 2, all divided by 4, because they both have a 4 in the denominator. Okay, so as you can see, we can come up with sines and cosines of some non-standard angles like the 15, the 75. All right, the next two, we're supposed to recognize those from our formulas. When the cosines repeat and the sines repeat, then this is a cosine. When it's a plus sign, it turns into a minus. And so that's the 65 degrees minus 5 degrees, which is the cosine of 60 degrees, which we know to be 1/2. When we see the sine, cosine, cosine, sine, when we see the sine and cosine alternate, then we know this is a sine. When it's a minus, we use the minus, and so that's 80 minus 50, or sine of 30 degrees. Sine of 30 is also 1/2. So now what's interesting with these difference formulas, you can simplify phase shifts for sine and cosine waves. So to simplify this, we know that it goes sine, cosine, minus cosine, sine, or sine, cosine, doesn't matter. So sine of x, cosine of 3 pi over 2, minus sine of 3 pi over 2, cosine x. Sine of 3 pi over 2, sine goes 1 at pi over 2, and negative 1 at 3 pi over 2. So that's going to be a plus 1 times cosine x, whereas the cosine of 3 pi over 2 is 0. So we're just left with equals cosine x. What that says is that if we took a sine wave and moved everything over (3 pi over 2), this point would move to this point. This point is going to move to this point. This one moves to there. This one moves to there. And this one moves to there. If we shifted that 3 pi over 2, we now have the graph of cosine x. And so we've proven that with its identity, as opposed to looking at it and saying it's true because of the graph. Okay, finding sine alpha minus beta, cosine alpha minus beta, tangent alpha minus beta, giving some information about sine alpha and sine beta. Again, we know that the sine of alpha minus beta is sine of alpha cosine beta minus sine of beta cosine alpha. Cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Okay, so it looks like we need some information here. Sine of alpha is 3/5. Cosine of beta, well, I know sine of beta. I don't know that yet. But sine of beta was given to me as 12/13. I know that one, but now I need cosine alpha. And so I have some work to do here. I have to draw these angles in their standard positions and figure out what these other values are. So let's see. Alpha is an angle in quadrant 1 whose sine is 3/5. And we should be able to recognize this pretty quickly, that this would be a 4, which means that the cosine of alpha is 4/5. So the cosine of alpha is 4/5. And then beta is an angle that's bigger than pi over 2 but less than pi, sitting in quadrant 2. And its sine is 12/13, and we're supposed to recognize this quickly as 5/12/13. But this is where you need to remember that in quadrant 2, the x is negative. And so remember, we were looking for cosine beta. That's negative 5/13. And so we put negative 5 here. So that's negative 15 over 5 times 13, 65. This is minus 12 times 4 is 48 over 65. Negative 15 minus 48 is negative 63 over 65. This gives us negative 63 over 65. Now cosine alpha minus beta is cosine alpha. Cosine alpha we said was 4/5. Cosine beta we said was negative 5/13. Sine of alpha was given. Sine of beta was given. So we have 4 times negative 5 is negative 20 over 65. And 3 times 12 is 36 over 65, which gives us 16 over 65. Okay, so for me, I don't like to move forward until I check this, that the sine squared plus the cosine squared equals 1. And so negative 63 over 65, when I square that, and 16 over 65, when I square that, this does in fact check out to equal 1. All right, so you don't, in this case now with tangent alpha minus beta, you don't need to know the formula for tangent alpha minus beta, because if we've done the work for sine alpha minus beta and cosine of alpha minus beta, then just divide them. Multiply by the reciprocal of 16 over 65, and we're left with negative 63 over 16. Okay, so let's do one more of these. This time alpha. So alpha is greater than pi less than 3 pi over 2. Its sine is 3 over 5. And so in order to be in quadrant 3, this sine of alpha was going to need to be a negative 3. And then we know that 3, 4, 5 right triangles, but in quadrant 3, that's going to be a negative 4. So now we know then that the cosine of alpha is negative 4/5 in that quadrant. Our beta is greater than pi and less than 3 pi over 2. So same quadrant. Cosine of beta is negative 1 over 3. And so then Pythagorean theorem, 3 squared equals negative 1 squared plus b squared. That's 9 minus 1 is 8. This is the square root of 8, or 2 square root 2. But we have to remember to put the negative on that one. All right, so now sine of alpha minus beta is sine alpha cosine beta minus sine beta cosine alpha. Sine of alpha was given as negative 3/5. Cosine of beta was given as negative 1/3. Minus sine of beta was not given, but sine of beta from over here, we can see as negative 2 rad 2 over 3. So we have negative 2 rad 2 over 3. And the cosine of alpha is negative 4/5. Okay, so what I can see is both denominators are going to be out of 15. This one's going to be positive 3. And this is going to be minus 8 radical 2. Cosine alpha minus beta is going to be cosine alpha, cosine beta, plus sine alpha, sine beta. Cosine alpha, we said was negative 4/5. Cosine beta, we said was negative 1/3, or I should say was given to us. Sine of alpha is negative 3/5. And sine of beta is negative 2 rad 2 over 3. All right, so this is going to be all over 15. It's going to be Negative 4 times negative 1 is going to be 4. Negative 3 times negative 2 is going to be positive 6 root 2. There's cosine alpha minus beta. The tangent of alpha minus beta is the sine over the cosine. Sine of alpha minus beta is 3 minus 8 rad 2 over 15. And this one's 4 plus 6 rad 2 over 15. When we flip it up and over and multiply the numerator by the reciprocal of the denominator, the 15s go away. We have 3 minus 8 rad 2 over 4 plus 6 rad 2. And this concludes the video for section 3.2 review.